Okay, so we're going to continue on with this problem session. Okay, and so this is going to be, and I'm just going to give you the representation 1 over, and I think I'm going to use a different color pen here. I'm going to go with blue. 1 over RT parallel is going to be equal to 1 over R3 plus 1 over R4. Okay, so if I were to add another resistor here, or just a whole bunch of resistors, dot, 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 should have 3 dots, then and if this resistor is R sub n, okay, this is going to be plus dot, 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 plus 1 over R sub n. Make sense? Okay, so when doing this, make sure that you guys should know that you need the common denominator, okay, in order to solve for this. Ultimately, you'll end up having something that looks like this: RTP equals to 1 over R3 plus 1 over R4 plus dot 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 plus 1 over R sub n to the -1 power. Okay, so we think that that pretty much covers what we are going to do. But um, yeah, it's going to pretty much cover. So, what's the technique that we would use? So, that's kind of like the background. But what technique would we use for this resistor configuration? Okay, so we're going to go ahead. I'm just going to copy this, go down here and paste this. All right, so the technique that I would use is I would take the parallel resistors, okay? And I would find my resistors in parallel, the total resistance in parallel, which is 1 over R sub C plus 1 over R sub B, all right? Which we know that this is just going to be RTP is equal to um, 1 over R sub C plus 1 over R sub B, and we're going to take that to the -1/2 power. Okay, so that would be my first thing. Now, since we have that, we can redraw our circuit, and now we have A here, okay, and we have RTP. All right, so let me just be a little bit clearer here. This is going to be R sub A. All right, it has a value. All right. So now we know how to solve this. This is just our resistors in parallel, and this is just going to be R sub A plus RTP. Now, if this is confusing to you in any way, what I'm actually doing here is I'm allowing this C to be R sub C, B to be R sub B, and A to be R sub A. Okay, and down here I'm doing the same thing. R sub A, R sub C, R sub B. All right. Um, so what now? Um, of course, we can do this in Microsoft Excel, and or we could just do this right here. So the first thing, let us look at the parallel configuration. Okay, so I am going to use this calculator this time. Should I do this in Microsoft Excel or should I do this here? You guys could, I believe that you just know how to calculate this right now, that you guys have the competency to do this. So what I'll do is I'm going to do this in Microsoft Excel because that should add to your skill set. Problem 4. And we have a resistor value for A. And I'm just going to say, or for resistor A, and I'm just going to call it 40,400. And no, I'm going to say resistance. Okay. So you see what I'm doing? I'm going to go ahead and fill this over. Mm, and whether you can do it, you could fill on the iPad or the desktop. Let me see if I can pull this, and I am going to wrap the text, and then I want to middle as well as center it. And let's make it readable. Okay. So now I'm gonna and I've left off my units, which is a major no-no. Okay, so our resistance here is just going to be 40,400, and then we are going to have 65100. All right, and then so that's 651 kilo ohms, and then we're going to have 393,000 ohms. All right, so we want to keep them in ohms. So I do have resistor A here, so you guys probably caught that, where this is actually resistor B, and then I have resistor C here. So we definitely have to go back to our original circuit, and this is our original circuit here. The first thing that we want to solve for is the resistance in parallel. This will be in ohms. All right. So our resistance in parallel is just going to be equal to um, power, correct? Because we're going to take this to the negative 1 power. So we have 1 divided by our first resistor value. Well, we have C and B here. So I'll do C, I'll do B, and then this is going to be plus 1 divided by C. And this is going to be to the power of a negative 1, and that should come out with a value, okay? And then we are going to have our resistors in series. And if you remember, we are moving down to this type of circuit, so our resistance in series. Yep. And this is going to be in ohms. Even though I'm saying ohms, we do not put the S there because that'll be an ohm times a second. And that can be confusing to your readers. This is just going to be equal to our resistance for the resistor A plus our resistance in parallel, the total resistance in parallel. Okay, so this is going to be the total resistance of the circuit. So even though it's resistance in series, yeah, it's resistance in series. This is equal to the resistance of the entire circuit. All right, this is what we should have here.